Yes, beta. So we have started collider solution in the last lecture. Now, in collider solution, just like in true solution, there is a solvent and a solute. In true solution, if we talk about true solution, there is a solvent and a solute, right? Same in case of collider solution. We have dispersion medium and dispersed phase. So we can compare dispersion medium with solvent. Solvent of the true solution is called as dispersion medium of the collider solution. In this case, we are not using the terms solute and solvent. Solutes and solvent terms are used in true solutions. For collider solution, we use dispersion medium for the medium in which substance is dissolved, and dispersed phase, the substance which gets dissolved. So it is solute in case of true solution. So dispersed phase and dispersion medium, these are the two terms. Sometimes we can write it as DM, dispersion medium, and DP for dispersed phase. If DM and DP is written in surface chemistry, that means DM is, it is not a deputy magistrate, okay, or manager. It is dispersion medium, and this is dispersed phase, right? Now, on the basis of their interaction, because when collider solution is formed, either they interact with each other, obviously they will interact, or something special could take place to make them together. Okay, so on the basis of their interaction with each other, they are classified as lyophilic salts and lyophobic salts. Okay, so let us do the classification on the basis of intermolecular interaction बोल सकते हैं, और interaction between dispersed phase and dispersion medium. They are classified as lyophilic salts and lyophobic salts. Lyophilic salts and lyophobic salts. Okay, is it visible to you? Yes. Okay. So okay. So that means we can done. So first property of difference, that is ease of preparation. How easily the one can be prepared. Now tell me, what do you mean by philic or phobic? Yes, what are the meaning of the terms philic and phobic? Just write in the comment box. What do you mean by philic and phobic? Just write. Do it fast. Lyophilic and lyophobic. What it means? Fast, beta, fast. What do you mean by philic? Philic means? Yes, I am expecting from you. Yes, attraction. And phobic means? And phobic means repelling. So that means in this case, attraction, so dispersion medium and dispersed phase attract each other. Dispersed phase and dispersion medium attract each other in lyophilic soils. And in case of lyophobic soils, dispersion medium and dispersed phase either no attraction or repel each other. Phobic means repelling. Okay, that means either between dispersed phase and dispersion medium, either there is no attraction or they repel each other. So that is case of lyophobic. Now, if they attract each other, they can be easily prepared. So, lyophilic soils can be easily prepared just by mixing. They can be easily prepared just by mixing with each other. Dispersed phase and dispersion medium, just mix them because they attract each other. They can easily prepare lyophilic soils. But lyophobic soils, either there is no attraction or they repel each other. So cannot be prepared easily. Special methods are required to prepare them. Either third component is added. Okay. Now, as there is a strong attraction, there is attraction between them, so they are quite stable and cannot be easily coagulated. Coagulation means precipitation. Coagulated or precipitated, or we can say separated. Dispersed phase from dispersion medium cannot be easily separated. Okay, cannot be easily coagulated or precipitated. Coagulation means just precipitation. Okay, means when dispersed phase particles come close to each other and therefore they form a bigger molecule. So that is called coagulation, and at the same time that is called precipitation, that you know all. Now, lyophobic sols, as there is no attraction and special methods are required or third component is added to stabilize them, means we need stabilizing agent in this case, so they are not stable, they are not very stable, though they are stable, because if they are formed means they acquire some stability, that's why they are formed, but they are not very stable and can be easily coagulated or precipitated. They can be easily coagulated or precipitated. Then, there is attraction between dispersion medium and dispersed phase. So if solvent is water, so we can say they are highly hydrated, they are not much hydrated, okay, because they will not attract each other, or even maybe they can repel each other. Therefore, a layer is not formed. Dispersion medium layer is not formed, means not adhere to the surface of the dispersed phase. Okay, in this case, that is always very close to the dispersed phase. Dispersed phase particle is always surrounded by dispersion medium particles because they attract each other in case of lyophilic sols. But in this case, they are not attracting each other. Therefore, layer is not very thick. Dispersion medium layer is not formed easily on the surface of dispersed phase. Okay? So these are the 4 points. Next one. Okay. Point number 5. Lyophilic sols, if they are separated by chance, dispersed phase and dispersion medium are separated, and if we remix, they can form sol. But in this case, if by chance we separate dispersed phase from dispersion medium, simple mixing will not form again the lyophobic sol. Again we need special method. That's why lyophilic sols, they are reversible in nature. Means separation and then remixing leads to the formation of sol. But in this case, separation and remixing, simple remixing, will not lead to lyophobic. So they are irreversible in nature. One is reversible, other is irreversible. Point number 6. Nature of the substance. Organic substances like gum, starch, proteins, form lyophilic sols. But in case of lyophobic, inorganic substances like metals and their sulfides form this type of sol. Right? Next one. What about viscosity? Means if we compare viscosity of dispersion medium and lyophilic sol, which one has higher viscosity? Obviously, in lyophilic sol, dispersed phase when added into dispersion medium, then dispersed phase interact with dispersion medium, and that's why make it more viscous. That's why viscosity of lyophilic sol is more than that of dispersion medium. What? Viscosity of lyophobic sol is almost same as that of dispersion medium. Now what about surface tension? So when particles adhere on the surface tension decreases. So that means in this case, lyophilic sol, dispersed phase particles, they are very much into dispersion medium, they interact with it, therefore balance the forces, balance the unbalanced forces, and therefore surface tension of lyophilic sols is less than that of dispersion medium, but surface tension of lyophobic sols is same as that of dispersion medium. So these are the 8 points of difference between lyophilic and lyophobic sol, but you have to write only 4. Total 8 points is for what then? If difference is there, if difference comes in CBSE board exam or any board exam, it is of 2 marks, maximum of 2 marks. If it is asked in 1 mark, you should write 2 points. If it is asked in maximum 2 marks, then you will write 4 points. Right? Now, why I have written all these 8 points? Because in competitive exam, any point can be asked. Right? That's why I have covered all the 8 points of difference between lyophilic and lyophobic sols. Right? Any doubt in it? Yes, beta. Any doubt? Okay. So let's go to next part. Next classification is on the basis of size of the particles or nature of the particles of dispersed phase. So on the basis of type of particles, it is classified as multimolecular colloids, macromolecular colloids, and last one is associated colloids. So multimolecular, macromolecular and associated colloids, what are they? First, multimolecular, as the name suggests. Its molecules are less than 1 nanometer. Means size of molecules is less. Molecules are, the size of the molecule is less than 1 nanometer. That means that particle cannot behave as colloidal particle, because colloidal particle size must be in between 1 nanometer to 1000 nanometer. Size should be in between that. So what would happen when we add a molecule having, means obviously there are million or trillions of molecules, okay? So when we add in the dispersion medium, then at that time these molecules combine together, means they make a particle of 100 or 200 molecules whose size is in between this range. We add it in the dispersion medium. In that dispersion medium, these particles combine together by van der Waals attractions. They combine together by van der Waals attractions, and 100 and so means more than 100 molecules, they combine together to form a molecule of colloidal range. Such colloidal sol is called multimolecular colloid. For example, gold sol, even sulfur sol. Right? Now, as there is a van der Waals attraction between the particles, that's why as there is a van der Waals attraction between the particles, then as there is a van der Waals attraction between the particles, so what it means? When temperature increases, they may break into separate molecules, okay, and that's why they are less stable. They are less stable. Okay? They are less stable. Means they are not quite stable, because when we increase the temperature or something is happened, the molecules may separate, and that's why multi-molecular colloid can break. Okay, means metal soles are under the category of multi-molecular colloid. Metal soles. Got it? And there is a van der Waals attraction between the different molecules. Done. Now macromolecular colloids. In macromolecular colloids, particles are already in the colloidal range. For example, starch sole. So they itself, single molecule can act as a colloidal particle. So simply those particles, when we add in the solution, add in the dispersion medium, they form macromolecular colloid and they are quite stable. They are quite stable. Then they are quite stable. Reason being, single particle can behave as a colloidal particle. Okay, and they resemble with the true solution in its sense, because in true solution there are single particles having size less than 1 nanometer, but here single particle having size is in between the 1 nanometer to 1000 nanometer range, and that's why that is called macromolecular colloid, right? So they are less stable multimolecular, macromolecular they are quite stable. Okay, now come to the third category. This is a special type of category that is called associated colloid. In this case, at low concentration, substance means dispersed phase particles, substance behaves as electrolyte. It behaves as an electrolyte. Okay, and at high concentration, above particular concentration, above a particular concentration, that is called CMC. What is CMC? Critical missile concentration. Or critical missile concentration, and above a particular temperature called Kraft temperature. What we call it as Kraft temperature, that is TK. That is TK. That is called Kraft temperature. Okay, so CMC, above CMC and above TK, these particles associate to form missile. And that is called associated colloid. For example, soap solution. So in soap solution at low concentration, those soap particles behave as a strong electrolyte, but at higher concentration they get associated to form an associated colloid. For example, yes, okay, good evening beta. Any doubt beta यहाँ तक? Okay, so mechanism of basal formation. Actually, soap is sodium salt of higher fatty acid. So at low concentration it behaves as strong electrolyte, but at higher concentration what happened, in the water, if concentration is low, then they are on the surface only like this, because this is hydrophilic part and this is hydrophobic and hydrophilic, that okay. So it behaves like this at low concentration, but when concentration increases, these particles enter into water, but only negative part is attracting water and rest of the part repelling. That's why what they do, they come near to each other like this. Okay, and in this way missile formation takes place. Okay, and if you would like to remove dirt, cleansing action of soap, so this is, let us take example of fiber where there is a dirt. So now in dirt, this is oily, this is hydrophobic, so hydrophobic part enter into it like this, so that will trap the oily part, hydrocarbon part, hydrophobic part trap the oily part, and when we shake it, this whole thing comes into water, because these parts, negative part, are attracted towards water. So when we shake the fiber, then what would happen? This whole thing in the form of missile comes out, right? So that is the cleansing action of soap. So today we have done lyophilic soil, lyophobic soil, difference between them, multimolecular, macromolecular, and associated chloride. Okay, so that's all for the day. Thank you so much. Bye bye beta.